Today I am going to start a new topic, chemical kinetics. You have studied in class 11 about the thermodynamics. Thermodynamics tells us about the feasibility of reaction. What we say, if the value of delta G is negative, the reaction is possible, and if the value of delta G is positive, the reaction is not feasible. Then we have studied about the chemical equilibrium, where the value of K tells about the extent of reaction. If the value of K is greater, the reaction will be with the formation of more product. If it is less, then there will be less product, and if it is in equilibrium, then that will be taking place at equal rate. But the branch of chemistry which deals with the movement of particles, that is known by the name of chemical kinetics. That means speed of reaction. We study about the speed of reaction and its mechanism only in chemical kinetics. But before telling about those reactions, I will classify reaction. The first reactions are known instantaneous reaction. The reaction of silver nitrate with sodium chloride gives us formation of AgCl with NaNO3. As soon as the reactant are mixed, there is a formation of a white precipitate takes place. We do not study rate of reaction in such reactions. The second one are extremely slow reaction that takes months to occur. Rusting of iron, formation of coal, setting of cement. The third one are the reaction which proceeds at moderate rate. Decomposition of hydrogen peroxide to give water and oxygen, hydrolysis of sucrose to give us fructose and glucose, oxidation of ammonia to give NO6H2O, the reaction of ethanoic acid with alcohol to give us ester. All these reactions proceed at moderate rate, and we study kinetic data in all these reactions. The first term that we use for the chemical kinetics, that is the rate of chemical reaction. Rate of chemical reaction is the change in molar concentration divided by time taken. Suppose there is a reaction, the reactant are converted into product. Initial concentration of these reactants is R1, final concentration is R2. The initial concentration of product is P1 and the final concentration is P2. The initial time is T1 and the final time is T2. Now delta R is equal to R2 minus R1, delta T is equal to T2 minus T1, delta P is equal to P2 minus P1, because delta means change. Now if we calculate rate with respect to R, it will be decrease in concentration of R divided by time taken, because when the reaction will be taking place, the concentration of reactant will decrease, and we just write minus delta R upon delta T. Why minus sign has been put? Because the rate of reaction is always positive. Now the R2 will be always show less and R1 will be greater. So we will get negative value, and negative will become positive. So this is the rate of reaction with respect to R. If I write rate with respect to P, it will become increase in concentration of P divided by time taken. That will be equal to delta P upon delta T. The concentration of reactant will decrease, but the concentration of product will increase.